Hi, I'm Benny D, and in this video we're going to look at using transformations to sketch graphs. So this is kind of one of those ones that brings everything together in a really nice way. So it's also best done with some examples. Our first one is sketch y equals 4 divided by x plus 5 take 3. Okay, the first thing we're going to need is a set of axes. Okay, y and x. Now we can see our basic equation here is actually y equals 1 on x. That's what we're starting with that's been transformed into this function. Now we can go through a really formal process of working out our dilations and all that sort of stuff, but we're not going to worry about any of that because we want to be able to do this in the simplest, easiest, and most straightforward way. Okay, that's what I'm going to show you. So we know we have y equals 1 on x. It's got a vertical asymptote, okay, that is the y-axis, and a horizontal asymptote, there's the x-axis. Basically, we just start going through and saying, well, what's actually happened here? What's going on with our function? And it's easiest to start with our x and work our way out. Okay, so we've got x plus 5. Remember, we need to switch in our heads a little bit what's happening here. So because it's a plus or a positive, then we move it to the left, and by 5 units. So we know that we've actually moved across 5 units, which is going to impact on our vertical asymptote here, okay, which is going to be at x equals -5. And we've also moved down 3 units. That's going to have impacted our horizontal asymptote, which will now be at y equals -3. Okay, and we can see here that we've been dilated by a factor of 4. You know what? We're going to ignore that, okay, because it's going to show up later on anyway. So we now need to actually sketch our graph. Okay, it hasn't been reflected at all, so we know we're in these two sort of quadrants. Okay, now the thing that we don't know is, does it go like this? Okay, something like that. Okay, or does it go something like this? Okay, or does it go actually through the origin? We don't know. Does it? Yeah, anything like that. Okay, so we've got a few different options of what it could do. I'll be able to work those out in just a second, and we need to, okay, because in any graph, it doesn't matter what it is, we need to show important features of our graph. Okay, and critically, they're our intercepts. So we absolutely have to show our intercepts. So we need to do our y-intercept. Okay, and remember, we find that by letting x equals 0. So we're going to do that in here. So we're going to say y equals 4 over 0 plus 5 is 5 minus 3. Okay, now we need to think about what this is going to look like. Well, we want some fractions going on here. To have a denominator of 5, I need to times this by 5 over 5, okay, which of course is going to be take away 15 on 5. Okay, well, 4 on 5 take 15 on 5 is going to be -11 on 5. Okay, and so we can see we're probably right here, our y-intercept, so we're looking pretty good here. So we know it's going to be down there. Remember, always label all points, including our intercepts, as sets of coordinates. So that's going to put us at 0, -11, -11 on 5. Okay, and look, we could convert that to -2 and a fifth, okay, but not too worried there, okay. So we can leave it at that -11 on 5. Now our our x-intercept, we let y equals 0. Okay, so we're going to do that. We're going to say 0 equals 4 over x plus 5 minus 3. Okay, we need to multiply by x take 5, so we're going to get 0 equals 4 take 3, lots of x plus 5. Expand those brackets, 4 minus 3x take 15. Okay, 0 equals 4 minus 15 is -11 take 3x. Okay, we're going to add on our 11. 11 equals -3x, so x equals -11 on 3, okay, or -3 and 2/3. So that's going to be this point here. Now we label it, okay, as negative 3 and 2/3 if you want, okay, or it could be a negative 11 on 3, 0. So we've done the coordinates. Okay, now we're going, how about that dilation factor? Well, actually, we're taking care of it. As soon as we have put in 2 points, and that's crucial, we have to have 2 points to show a dilation factor, not just one, okay, then we've actually shown this dilation factor of 4. Okay, we actually don't need to worry about doing any more than that. Right? So taking care of that dilation factor. So we'll have a look at another worked example. I'll grab a different board here. Second worked example for this one. Let's go with y equals negative square root of x. Actually, what I'm going to do is I'm going to change this slightly and say 2x. Actually, I'm going to say negative 2x plus 2a plus 5. Okay, so what we need to think about, what's my original function? Well, really my starting function is the square root of x. Our starting function, so what are we going to need? Well, we're going to need a set of axes, labelled y and x. Okay, and we need to think about what's going on. Now, the first thing we're always going to do with a function that has a dilation factor within it, okay, is we're going to take out negative 2 as a common factor. So our function then is going to change to be y equals negative square root of negative 2 outside of x take 1. Okay, now that is critically important, plus 5, because if we're looking at our translation, our horizontal translation, if we had not done that, we would have been saying, oh, it's been moved 2 units to the left. Incorrect. Okay, our function is actually being moved 1 unit to the right. Critically important first step. Anytime you see any sort of dilation factor, it doesn't need this reflection as well. Our dilation factor, we need that. So we know one of our important points is our starting point here. It's usually at 0, 0. Now we can see that point has actually been moved across by 1. Okay, we've been moved to the right by 1. Okay, we've got this dilation factor. Remember, I don't care about that at the moment. We'll sort that out. It's also being reflected in the y-axis. Okay, so now it would, instead of looking like this, we're now going to be looking like that. Okay, but it's also being reflected down. Okay, reflected in the x-axis as well. So it's down, it'd be looking like it's down here, but we've been moved up 5. We moved up 5. So it's going to be, now again, we don't know at the moment, what's it look like? Does it come down here through our positive x-intercept, okay, and a negative y-intercept, or we're going to have a positive value for our y and x-intercept? And I think that might be the case, so I'm just going to go like this, just to get an idea. Okay, if we're not sure, we can work out our x and y intercepts first. Okay, and this dilation factor is going to be taken care by the fact that we're labelling 2 points here. Now this endpoint needs to be labelled. Okay, so that's 1, 5. Now that is one of the points. As long as I showed one other point, okay, I would get my dilation factor shown, but we should always show both of our intercepts. So again, I'll start with my y-intercept. It's always the easy one. Y-intercept, let x equals 0. So when I do that, I get y equals negative the square root of negative 2 times by 0 take 1 is negative 1 plus 5. So y equals negative root 2 plus 5. Okay, well, root 2, okay, is about 1.41. Okay, so negative 1.41 plus 5 is definitely going to be a positive value. So this point here is 0. Negative root 2 plus 5. Okay, or a nicer way to write that is going with 5 take root 2. And then we need to do our x-intercept. I'm going to let y equals 0 this time. So 0 equals negative the square root of negative 2 times x take 1. Okay, plus 5. I'm going to take my 5 away, and then I'm going to do 2 steps at once. I'm going to take 5 away, and I times everything by -1 to get rid of that negative. It means I'm going to be 5 equals square root of -2 x take 1. Okay, I'm going to square both sides to get rid of my square root. Gives me 25 equals -2 x take 1. Okay, I'm going to divide by -2, giving me -25 on 2. So x take 1. Okay, add 1 on to give me -23 on 2. Okay, equals x by adding 1 on to the other side. So we see that is definitely a negative value. Okay. Now we need to be careful with scale here. I've drawn this incorrectly. It would need to coming up more like this. Okay, only because I've already given this value as 1, so my scale has already been set. Okay, and I'm probably going to be slightly dodgy here as well anyway. -23 on 2, 0. Okay, for my other one. Now we had that dilation factor. There's 2 here. Well, that's been taken care of in labelling these points here. Okay, so key things to note, don't stress about dilation factors. As long as we show a couple of points, we are fine. Okay, the second one is always factorise. Okay, if you've got something a little bit more complex with any of our functions, since we've got this dilation factor in there, we must factorise. Otherwise, we're going to muck up our horizontal translation. Okay. So hopefully that'll be enough to get you through the questions on this section.